So hello everyone. In the last video, I have seen about the basics of a data specification, which gives the semantics to the data. And in the current video, we will see the researches in the pylearn2. So the pylearn2 is a release under the three clause BSD license. So it may be used for the commercial purpose, and the licensor does not require anyone to cite the pylearn2, but you can use the pylearn to between the, you can say, the one research paper that is about the pylearn to the machine research library by the Ian and the David. So it's tell about the what is the introduction about the what is the pylearn to, the classes library, the core component of the pylearn to, the licenses, cited information about the history, and the final implementation, not the implementation but basics, the development workflow, and the user community, and the final the conclusion about it, the pilot. So it's a research paper in 2011 2013, when I have previously said that it is in between when the research community pilot to gained by the special attention by the research community, and this is a pilot to the machine research library. It can be used unusual or involve a new or unusual use cases. So, brief history about the library, about the philosophy, about the library architecture, the description about how the pilot community functions socially. So, these things are described in this paper. So, it's a basically a very good reference paper for the pilot. So, if we talk about the features in pilot, training algorithms, the first things, the first training algorithm, the next, the model estimation criteria, the models, and the data set. So, if we talk about the first things, the training algorithms. So, training algorithm basically that ask the model to train itself. Any machine learning based model, any AI based model. So, training algorithms are used to train this model accordingly. How many features in the input features, how many features we have to train our model. So basically these things are there. So training algorithms, data rate of decay, learning rate of decay, because learning rate is a fix how we learn, and to basically learn our gradient descent. We have to find the optimal position. To test the gradient descent with the extension, including the learning rate of decay, the momentum, polyac, averaging, and early stopping things that okay, the stopping criteria we have fixed, and we have to find like okay, early stopping before stopping or after stopping things are there. So basically a simple framework for adding your own extensions basically in the training algorithms, and the batch gradient descent with the line searches, non-linear conjugate gradient descent with the line searches. Basically training algorithms, so what type of training algorithms are used in the pilot tool. Next thing is the model estimation criteria. So model estimation is the maximum likelihood. The cross entropy. Entropy is basically the possible find the information gain, the what information in the max. Score matching. Things are there. Denoising, score matching, and the noise. Basically, the denoising, the score matching, and the cross entropy. These are the things are there, and the log likelihood and the noise estimation, noise conservative estimation. So noise contrastive information is basically about the that okay, when we model we are find which model we are which are very efficient in Python 2. So basically the model estimation criteria that works for basically the noise, find the noise, basically find the how many noise are um, in this machine learning algorithms. So basically, the what is the exact estimation of this model? So these are the criteria that test for the model. And if we talk about the models, so autoencoders, including the contractive and the denoising autoencoders, and RBM, including the Gaussian and SSS RBM, and various level of integration into full framework. K means that the tutor decided okay which point we have the nearest one, find the equivalent distance between that, and we take In shorting for the equivalent time, find the estimation. So K means maximum network, the PCA, it's automated mainly used in automation PCA. The spike and the slab sparse coding and the SVM support vector machine, in which we provide a wrapper around the skeletal and that makes it easy to train a multi-class SVM, multi-class SVM, one or more classes. Basically, the SVM is a say there are two classes SVM in which our predicted output will be a y or no. In the suppose exactly we take an example. So if x is a feature vector and we have a feature vector is given, so we have to predict what is the y, what is the predicted output. There are two layer classes. Multi-class SVM in which more than two classes exist. So that's the multi-class SVM. Or the dense training data in a memory efficient way. Dense training data. It simply means that okay, the training data is a dense. It's not in the simply say the linear one, and the memory efficiency. Memory efficiency play a vital role in the to predict the exact to predict the output. So how many memory efficient? So this is the basic things are there, and the partial implementation of DBMs, database management system. So contacted the IAN have been say uh, if you would like to complete it, okay. So basically, Ian good have worked. I have previously mentioned my slide. In 2013, the pylearn2 research library. So I will mention the contact Ian for your like to complete it. So partial implementation of DBMS is basically practical implementation things that we did research about the pylearn2. So I will describe the training algorithms, order training algorithm, momentum, the polyag, the base gradient, heuristic gradient, the model estimation criteria, the quotient for field of likelihood, score matching, and the models. Next are the data set. The basic things are data set. So various data set we can use. The first thing in MNIST, I have defined MNIST with the background and rotations, rotation imaging are there. CIFAR, so CIFAR 10 and CIFAR 100. So I will talk about the previous CIFAR 10. So I will tell you the what is the CIFAR 10. So if we talk about what is the CIFAR 10, what type of a data set CIFAR 10. So we will see that okay, what type of data it's a type of. So CIFAR data set containing 60,000 32 by 32 color images in the 10 classes: the airplane, automobiles, the bird, cat, deer, dog, frog, horse, and ships. Various others are there. So basically 10 classes, the 10 random images from the each. It takes a airplane, the 10 random images from the airplane, each of us, each of the classes. They are the 50,000 training images and the 10,000 test images. Now about 60,000 total data set. So 50,000 million used for training, and the next is now for this. 5 batches it is defined. One is test batch and 10,000 images, and 50 is the training data set. So the test batch contains exactly 1,000 randomly selected images and from the each class. Each class is taken 1,000 random selected images. So it's about the CIFAR 10 data set, 10 classes, and basically some training batches that may contain some images of this like that. So if we talk about the data set we are using, so CIFAR data set and STL10 dataset, CIFAR 100, NIPS Workshop 2011 Transfer Learning Challenge, Open Learning Challenge, and NORB Toronto Faces dataset, and UTLC. So there are various dataset, but mainly we have important. We have talked about the say MNSIT dataset and CIFAR dataset using pylearn2. So uh, these are all about the dataset. And we talk about the dataset pre-processing. The things are there. So dataset pre-processing means that contrast normalization. That okay, some type of dataset we require some operations, and these operations are set ZCA, whitening, some whitening, background whitening of the images, and the image is not suitable for the learning, some learning operation or some testing operation. So these are data set pre-processing technique. The contrast normalization, we have to normalize the contrast value of RGB or some color combinations like that. ZTO whitening, the patch extraction, the various patches, if there are images, various patches are defined. So patch extraction for the implementing using the foundation like algorithms, combination neural network, two layer, three layer, multi-layer neural network, and the codes, very codes. So codes D plus DIS API processing pipeline. So data, these are the some data set pre-processing techniques, some pre-processing techniques in the pylearn2. So in this current in the current slide, I have explained okay the features about the pylearn2, the researches, the previous research about the pylearn2, the model estimation criteria, and the models about the models in the data set, about the data set, which data set we are using, data set pre-processing techniques. And in the next slide, I will tell you about the basically about the code example. What is the exactly code sample using the pylearn2, and how we test the model, how we train the model, the various using various machine learning algorithms, and implementations. So these things I will tell you in the next slide. So keep watching. Thank you.